afternoon. My name is Milad Bagheri. My supervisor, Dr. Zalina Zaytoun Ibrahim. This is the first part of my thesis. My thesis has three parts, three projects, and this is the first project for simulation and forecasting sea level rise for Kuala Terengganu by using a neural network model, two kind of model. Outline of study, introduction, problem statement, significance, objective, study area, methodology, and data collection, result, and conclusion. While the human population living in the coastal zone is increasing approximately 70% of world, beach are retiring, 20% is stable, 10% is advancing. Most of the megacities are located near the sea, and like the Sydney, Shanghai, and the shoreline area is a rich environment of high biological and physical diversity. The sea level rise, global sea level rise trend upward. So in the Malaysia, the base of National Coastal Vulnerability Index study is required to identify coastal area exposed to affect the sea level rise. And you know, after sea level rise, we have some flood, some inundation and erosion in coastal area and coastal city area. And for based off the DID, the latest report in 1985, the Kuala Terengganu have extreme erosion. So this is the problem statement based on literature review about the moon season and some flash flood, lowing area, and change in sea level and human activity. Our framework for this project. We have two parts. The first part data analysis and another one modeling for neural network. We use two model, NARX model and feed-forward. And for each model, we have a simulation and forecast for sea level rise based on IPC scenario. This is our study area. Our study area from Merang, Kecil Andim, Kuala Merang. And here, this side of the study area, South China Sea, and here you can call it Kuala Terengganu city. It is a big city in Terengganu state, and have a very big, so huge river, Terengganu River here. Our objective forecast prediction for future trend, sea level rise, and we use the method artificial neural network model, and the results simulation and predict sea level change from 1991 until 2020. This is the tide gauge analysis. We use some non-parametric tests and data and some filtering analysis, and we use the tide gauge observed daily data for 1985 until 2012, and we collect from INSPEM. You can see this data have some missing data and outlier data. So we use a box plot, and you can see we have some outlier. And we replace the data with we use some model, and we choose, and after get the result, we choose best model moving average and replace missing data. And you can see the annually mean sea level 1985 until 2012, and you can see the trend, so sea level rise upward. We use observe tide gauge and simulate tide gauge. We simulate tide gauge, for tide gauge in INSPEM, and INSPEM have a specific special software, tide gauge system software, and use that software in the INSPEM for simulate. And after that simulate, after get the result, we have observed data for tide gauge and simulate data. And after that, we remove all the pattern for tide gauge and generate the sea level residual. And you can see this one, the sea level residual, and yeah. And after that, we compare sea level residual with the some data, SOI and IOD, data, Indian Ocean Dipole and Southern Oscillation Index. And you can see some years we have low sea level and high, because have a high sea level pressure, about the El Nino and La Nina. And this is the collection for this project. For the input, neural network input, we use the 5 predictor: wind, sea surface temperature, sea level pressure, and rainfall, and tide gauge. We collect from MMD, some agents of Malaysia, MMD, JUPEM, and some popular sites, CMIP for IPC scenario 3. And for artificial neural network learning is biological systems involve adjustments to the synaptic connections that exist between the neurons. So for our project, we use the 2 models, NARX model and feed-forward. Feed-forward is the famous model for neural. Have a 3-layer input and hidden and output layer. For feed-forward, this is architecture for feed-forward input, and have a 2 function, and we use the Lerrenberg LM algorithm for this model. And this is the process for feed-forward. After normalize all the data input and output, and put the feed-forward model, and we for the training, validation, and testing, we divided for the training 60% data, and for validation 20%, and for testing 20%. And after that, make run the model, and we run 100 times until find the best MSE and R-square. For this is the simulation result for feed-forward, based on training and validation testing MSE and R-square, and this is that one the simulation result until 2012. I have upward trend, and this one after fix the model and find the best model, the feed-forward model. We put the prediction data in the model and forecast sea level rise until 2020, and you can see from 1991 until 2020 we have a upward trend for sea level. For NARX model, same as feed-forward, we have a 2 function and 1 algorithm, Lerrenberg algorithm, but for this model we use a daily and lag. And the process same the feed-forward, but we choose the lag for this model. And this is the simulation for the result simulation for NARX. After 100 times, we find the best architecture neural network NARX with the 4 lag and 5 input, 4 lag and 6 hidden layer, and 1 output. This is prediction, and the best model between the feed-forward and NARX model. NARX model is best based of the result training performance for neural training and validation testing. And for conclusion, the first one, we find the best model from neural network, the NARX model performance better than feed-forward model to predict the sea level rise. in Kuala Terengganu, and the result indicates the upward trend for sea level rise in Kuala Terengganu coastal area with minimum rate 1.03 millimeter per year and maximum rate of 21.85 millimeter per year from 2013 and 2020. And actually we use this result, it's important for this result for us. Exactly we need this result for Kuala Terengganu sea level rise because we put the result in another model for predictive erosion, coastal city erosion for Kuala Terengganu based off sea level rise. And I hope this result is useful for some researcher, and thank you so much.
Is there any questions?
Thank you for your presentation. Have you taken into account the changes of vertical and motion from GIA or earthquake?
With this model?
Yes.
Actually, I don't know. About the earthquake, or, but I think can because I read some article about the rainfall. We can predict with this model for rainfall or tide gauge, sea level, and flood. You can use this model, but for earthquake, I don't know if I think can, but.
Just a comment. In my personal opinion, your predicted values is quite large, so maybe you can compare with the one from Singapore. I think they made a prediction.
Yeah, actually we compare the result compared with another research from the GIT or NARX in Malaysia, but another country no. But compare the result. Yeah.
Any questions?
Do you define the similarity from meteorological calculation in your study?
Sorry, I just.
Do you discuss the similarity according to meteorological calculation?
No, actually.
Just asking with Zamitan Mama Ali.